teaching lessons with Dom. So we start off with, this diagram thing, as you can see. Basically what you want to do is you want to break it up into components. Just draw those triangles here, okay? Then you get the angles of each one, which are labeled in this problem here. So 67 goes there, 43 goes there. Then after that, you're gonna make these 4 equations. Basically, a trick for this is you want to put your T1s together and your T2s together. For X, it's going to be cos, and Y, it's going to be sine, but only for translational equilibrium. If it's an incline, it's flipped, but we'll get to that. So on this here, we have 4 equations. We want to use, the way to form these 4 equations is right here, but a simple way is just to memorize it. Simple, T1x equals T1 cos 67. Once you get one equation down, just use it as a reference to get the others. Once you get that down, you want to make a system of equations. You're always going to make 2 equations, one for the x and one for the y. So the y equations more complex, but the x is simpler. The x is just setting both x equations together. So the T1x and the T2x. The y equation is both y's have to equal 74. Okay, so that's the trick. T1, the x's have to offset each other because it's not pulling horizontally, it's pulling vertically. So once you get those 2 equations, you have to rearrange the T2 equation for x. So you want to get x there. So you want to rearrange this x equation and set it equal to T2. Once you set it equal to T2, you plug T2 in to this equation. You plug this T2 that you get from the x equation to the y equation. Then you make the substitution. You make where it says T2, you put that in times sine 43 there. Okay? And then you solve for T1 and you get 58 newtons. Then you take this number and you put it in to this equation, this equation, to find T2. Now, T1 and T2 are not going to equal 74. I don't know why, it's stupid, but it's not going to equal 74. And on the quiz, we had the T3 problem, or we had like T1, T2, T3. T3 is going to equal that mass. So it's going to equal 74. So that's what T3 would equal. And that's problem 1. So this problem is an inclined plane problem. I think this one's easier. So basically, we're going to start off by reading this part. It says landscaper is doing some lawn work, 2.0 kg tire, and then a 30 inclined hill. That's all you really need to know. So you draw, I draw the triangle, you put 30 degrees right there, and then right away solve for FG. FG equals mass times gravity. So you're gonna take the 2.0 kgs given times negative 9.81, which is gravity, and you get 20 newtons. So it's negative, FG equals negative 20 newtons because FG is going down. So you want to know that. And that goes there. Then you're going to draw this little triangle right here and set it to FGY and FGX. Then FF is friction going that way. FN is going this way because it's opposing gravity. So once you get FG, then you put it into FGX and FGY. FGY uses cos in this one, and FG(x) uses sine. So you do FG times whatever your sine or cos, 30, and then you get your 10 newtons and 17 newtons. So you're going to put 10 newtons there for FG(x) because it is going forward. And then you get FGY, which is going this way. It's going to be negative, so it's going to be negative 17. And then Fn equals Fy, because these two are opposites and they have to equal. So Fn is going to be plus 17 newtons right here. So plus 17. Then to find FF, they give you the coefficient in the beginning of the problem right here. So you're going to take that 0.4 and the force of friction, and friction equals the mu times Fn or Fy. So 0.40 times Fn equals 6.8, and it's going to be negative because it's going left. So then you're going to put negative 6.8 newtons there. And then F net is another equation. I'm pretty sure, does she give it to you? Yeah. No, F equals MA, but you want to use FG(x) minus FF to get F net. So F net equals FG(x) minus FF. Plug that in, you get 3 newtons. But you get plus 3 because it's a positive force and it's going downwards. And then use F net equals MA to find acceleration. And that's going to be just plugging into the equation here. And you're going to get 1.5 meters per second squared. That's where you're going to get your acceleration. Now, on the one she gave us on the quiz, she gave us one where it was constant velocity. When it says constant velocity, that means the F net is 0 newtons and acceleration is 0 meters per second squared, along with the force of friction is going to equal Fg(x) because they have to offset, and Fn is going to equal Fg(y) still. And there's your lesson.